Namaste, welcome to the class. We have the 42nd question, right? You might have seen this question in wave optics when we were discussing about interference. Same type of question. A sound wave of wavelength 32 centimeter enters the tube at S as shown in the figure. So we have a tube like this, and this is bent like this here. So this is the part which is closed, and we have a sound source, a speaker here producing sound, and that travels. Then the smallest radius are so that the minimum a minimum of sound is heard at the detector D is minimum or maximum? Yeah, minimum sound is heard at the detector D. Yeah, okay. So let this sound travel like this, and it's split into two, like this and like this. Now the thing is, by the time sound travels like this and reaches here, and the sound travels like this here, the two sounds, when they travel like this and reach here, the other sound has to travel larger distance and reach here, right? By the time it reaches here, the crest of this should fall to the trough of this one. Then only they will cancel each other. You just go back to that interference chapter. There we have discussed a similar type of problem, but there we have discussed it for maximum sound. Here maximum sound. For the maximum sound formation, the path difference should be 1 lambda. For minimum sound formation, the path difference should be half lambda, because one wave should travel like this and another wave should travel half lambda less. So you started from here, this is 1 lambda, started from here, then it travels like this, crest falls on crest, trough. So the distance, what is the extra distance traveled by this wave? It is the circumference by 2, that is 2 pi r by 2 minus this distance. What is that distance? Double the radius, right? Double the radius must be equal to lambda by 2, because they are asking you the minimum sound should be heard at the detector here. So path difference should be lambda by 2. Actually it is related to that chapter, but still it can be asked here also. 2 gets cancelled. R into 3.14 minus 2 is equal to lambda by 2. Radius is given, right? So that then the smallest 32 centimeter sound wavelength is given. Smallest value of radius is 32 centimeter. So smallest value means you have to put the minimum condition, lambda by 2. Even for 1.5 lambda, 3 lambda by 2, again you get a destructive interference. Okay, so this one, how much is lambda? 32 centimeter. So R into this is 1.14, correct? Is equal to 32 by 2. R is equal to 16 divided by 1.14. What is 16 divided by 1.14? Slightly less than 16, maybe 14 centimeter. I don't know exactly, it may be 14. That is the nearest answer. Okay, the minimum distance of sound, a minimum radius, so that destructive interference is formed. 43. A sonometer wire under a tension T emits a note of fundamental frequency 200 Hz. Wire of frequency to F is proportional to root T, because it looks as if we are playing with frequency and tension. A sonometer wire of tension T emits a fundamental frequency of 200 Hz. The tension is increased by 3T. Very careful. Not 2-3T. By 3T. What is the new tension? 4T. What is the fundamental frequency? Divide this. F by, of course, it is 4 times increased. Root of 4 is 2. 2 times 400 Hz, right? Yes, this is the answer. Divide this. F by 200. Root of 4T by T. Cancel. 2 into 200. 400 Hz. Yes. 44. In a Welded experiment, what is Welded experiment? That is a wire is, you stretch a wire and keep on vibrating it. That is Welded experiment. In a Welded experiment, the string vibrates in 2 loops when a tension of 2 Newton is applied. Tension to be applied to make the same string to vibrate in 4 loops. So who is fighting in this match now? It's a kabaddi match and 2 people are fighting. Who are the 2 people? Only retain those 2 people in the formula. F is equal to number of loops 2L square root of T by mu. Same experimental setup, same wire, Mass per unit length doesn't change. Tension is in competition. Length is not in competition. 2 is not in competition. Number of loops is in competition. Frequency not in competition. Nothing is told about competition, frequency. Number of loops to make the tension, right? So how can you treat it? Number of loops is inversely proportional to root tension. You have to compare it on either sides of equal sign. N is inversely proportional to root T. Now you write it. Vibrates in 2 loops when the tension is 2 Newton. Tension to be applied to make the same vibrate in 4 loops. 2 loops, 2 Newton. What tension? 4 loops. Divided. 2 by 4 is equal to by root 2 root T, square it, 1 by 2. 1 by 4 is equal to T by 2, half, right? N by, now what did you find out? First one, 2 Newton, okay. In a Welded's experiment, the string vibrates in 2 loops when a tension 2 Newton is applied. Tension to be applied to make the same 2 vibrates in 2 loops. 1 Newton by 2. Now something has gone wrong here. 2 Newton, then what is this? Options N by 2, what is N by 2? 1 by 2. Tension is 2 by 4, that is 1 by 2. 1 Newton, this Newton is the answer. So many Newtons by 2. 1 Newton by 2, yeah, this one, correct? 1 Newton by 2. Yeah, only the thing is, see, when the 4 loops means number of loops is inversely proportional to tension. 4 loops means tension has to be increased by 2, right? Because half, am I right? 2 loops, root of 2. And 4 loops, what root T? 2 by 4, 1 by root 2, root T, 1 by 2, 1 by 4 squared, T by 2, yes, half, N by 2. 44, third one. 45. The frequency of first overtone of a closed pipe of length LC. Frequency of the first overtone of a closed pipe of length LC is equal to that of the second overtone of open pipe of length L0. The ratio of L0 by LC. Frequency of the first overtone, okay, open pipe I'll write. I'll write it and keep it here. It is needed. Open, closed. Okay, closed. Open pipe V0 by 2L, V by 2L, V by 2V by 2L, 3V by 2L, V by 4L, 3V by 4L, and 5V by 4L. 5V by 4L. Fundamental. And this is first overtone, second overtone, and this is second harmonic, third harmonic, fifth harmonic. Now their question is the frequency of the first overtone of a closed pipe. Is equal to the second overtone of an open pipe. Right? 3V by 2L0. I have to turn this L as L0. The frequency of the first overtone of closed pipe. First overtone of closed pipe is 3V by 4L. Second overtone of open pipe, V by 2L, 2V by 2L, 3V by 2L. All multiples. Yeah, what is L0 by LC? L0 here, LC here. Here, right. 3V gets cancelled. And this is 2 times. And I'll bring this here. L0 by LC is equal to 2, right? Option 2. 46. A string A has twice the length, twice the diameter, and twice the tension, and twice the density of string B. What overtone of A agrees with the frequency of the fundamental of B? AB we'll write, AB. A has twice that of B, right? So we will define it for B. L, twice the length, twice the diameter, diameter or radius. It is one and the same, radius and diameter. If radius is out, diameter is out, radius is out. Ratio wise it is same, twice the diameter and twice the tension. A has twice the tension and twice the density of string B, 2 rho. What overtone of A agrees with the frequency of the fundamental of B? Yes. Yeah, we will write the formula. Frequency here of B is equal to 1 by 2L, fundamental layer, right? 1 by 2L into square root of T by that mu can be written as R squared, pi R squared rho, right? Pi R squared rho. What about here? Frequency is equal to 1 by 2L. So shall I write it somewhere here? F is equal to 1 by 2 times 2L square root of T by pi R squared. R squared is 4R squared rho, 2 rho. Everything is 2 times. What is this one? F equal to. So how many extra terms we will get other than the usual formula? 1 by 2L into square root of T by rho. Instead of this, how much you will get? This 2L, 2. This 2 will get cancelled with this 2. 1 by 4 we have and 1 by 2 outside the square root. So you will have 1 by 4 extra. This 1 by 2 and this 1 by 4 square root 1 by 2. Now that means this is frequency of A. Yes. Frequency of A by frequency of B. How will be the formula? Rho pi R squared rho. Pi R squared rho. Everything here. Pi R squared rho, and except that 1 by 4. 1 by 2 will be here. This 1 by 2, 1 by 4. Frequency of A by frequency of B is equal to 1 by 4, isn't it? FA by FB, everything will get cancelled except this 1 by 4. Now, 4 times the frequency of A is equal to frequency of B, correct? That means fundamental frequency of B is 4 times the fundamental frequency of A. Am I right? Fundamental frequency of B is, am I right? FA by FB, FA is 1 by 4, FB is 1. That means 4 times the fundamental. Frequency of B is 4 times the fundamental frequency of A. Now what is the question? What overtone of A agrees with the frequency of the fundamental of B? Fundamental frequency of B is 4 times the fundamental frequency of A, means it is the third overtone, right? Fourth harmonic, but third overtone, because fundamental is not overtone. Next overtone, fourth harmonic, that is third overtone. Third overtone of A, that means 4 times the fundamental of A, agrees with the fundamental of B, right? Third is the answer. This was last answer, right? Yeah, 46-2. Hope you have followed it. Since FB is equal to FA, for example, for FA, FA is 50 Hertz, then what is FB? FB is 200 Hertz, right? 4 times. What is 200 Hertz? 200 Hertz for FA is, it is 4 times. That means third overtone, fourth harmonic, right? So that is the answer. 46, 47. Yeah, we have to finish it now. An open pipe has fundamental frequency of 100 Hertz. What frequencies will be produced if one end is closed? Yeah. An open pipe has fundamental frequency 400 Hertz. That means V by 2L is equal to 400. What about closed pipe? What frequencies will be produced if one end is closed? If one end is closed, then for a closed pipe, V by 4L. Correct? How do you write V by 4L? If you want V by 4L, you have to multiply this by multiply this by half. That is 400 into half, that is 200. Correct? 100. This is 100. Yeah. Fundamental frequency of an open pipe is 100. and if it is closed, length will remain the same. Now closed pipe will have a fundamental frequency of V by 4L. That means you have to multiply this by half. V by 4L is 100 by 2, that is 50. So what is the range of frequencies produced? It is a closed pipe, 50, 3 times 50, 5 times 50, 50, 150, 250, yes. That is the range of frequencies produced. 48. A cylindrical tube open at both ends, means open pipe, has a fundamental frequency F in air. Okay, the tube is dipped vertically in water so that half of its length is in water. Then now the fundamental frequencies. Okay, fundamental frequency of open pipe is V by 2L. Now the tube is dipped with the water, in water. So in water, when you dip it, half is dipped in water, right? What about the remaining half? This is V by 2L. Suppose 1 by 4th is dipped in water, 3 by 4th is the length, but here it is given half, so you are safe. Other half is also half. V by 2L. Now, yeah, this is the so remaining half is the length. Now what is the closed pipe fundamental frequency? It is the new fundamental frequency of the air column. Yes, this is F. Open pipe, yes, that is equal to F naught. Closed pipe, V by 4. What is L? L by 2. Because new length is L by 2. For closed pipe, length is only half of it is remaining in air, half is immersed. So what is this one? This is equal to V by 2L itself. That is F naught itself, right? The fundamental frequency hasn't changed. So since length has halved, the frequency should have been halved. But the fundamental frequency of open pipe, closed pipe is V by 4L. So there it has agreed, right? So V by 4L, L is L by 2. So it has become V by 2L itself, F itself. 49. A sonometer wire 65 centimeter long is in resonance with the tuning fork of frequency F. Okay, so you have a wire which is 65 centimeter long and pluck it. It produces a tuning fork of frequency F. Same. It is in resonance with the tuning fork of frequency F. Frequencies are same. If the length of the wire is decreased by 1 centimeter, 64 centimeter, with the same fork F, it produces 8 beats per second. What do you mean by that? This length is decreased. We have a clue. When length is decreased, frequency must increase. That means F is equal to 1 by 2L into square root of T by mu. When length is decreased, frequency must increase. That means this should be, if F is the frequency of the tuning fork, this should be F plus 8. Frequency must increase, 8 beats they have given. So with this you can solve the problem. How? Right, F is inversely proportional to L. F is inversely proportional to 65. F plus 8 must be inversely proportional to 64. How did you come to the conclusion that F plus 8? Length has decreased, frequency must increase. But now it gives 8 beats. 8 must have been 8 beats or 8 hertz should be the extra frequency gained by this. This is remaining the same, so 8 beats. Now divide them. F plus 8 by, now what is the question? What is the value of F? F plus 8 by F is equal to 1 by 64, 60 by 64. We have to multiply this now. Okay, we will multiply. 64 F plus 351 is equal to 65F. 65F minus 64F, 512 itself. Same answer. Because this is 1F, 1F is equal to 512. Hope I am doing proper. 65F, 512, yes. 65F. That is 512 hours. So simple logic, F is inversely proportional to L. As L is decreased, the frequency should increase. When a sonometer wire is plucked, 2 beats are heard with the tuning fork of frequency 512 hours. Okay. When a sonometer wire is plucked, 2 beats are heard with a tuning fork of frequency 512 Hertz. What do you mean by that? This should be either 514 or 510. Recall beats. Recall that idea. 510 or 514. But how to come to know whether it is 510 or 514? On slightly increasing the length. Okay, L plus delta L. So slightly increasing the length. That means frequency should decrease here, right? And slightly increasing the length under constant tension. Again 2 beats are heard. What are you doing here? Suppose F is the frequency here. Here F is decreased because F is inversely proportional to L. Increase in length decreases the frequency. The frequency of the wire before increasing the length is. We will go for our graph. 512 is the frequency of the tuning fork. This is tuning fork, okay? And the answer should be either 514 or 510. 2 beats, 2 beats. Now, when frequency is decreased, that means length is increased. 2 beats are heard. So this is 514 or 510, right? And among them, 514 or 510. Now what are you doing now? When length is increased, again 2 beats are heard. Length is increased means frequency is decreased. Frequency is decreased. If this is decreased, this may come to 512. This may come to this value, right? Again 2 beats are heard. If this is decreased, it will keep on decreasing and it will keep on increasing the difference between 512 because tuning fork is constant. If this is the answer, this may come here and produce again 2 beats. If this is the answer, this will never produce 2 beats with this one. 514 is the correct answer. Okay. 51. A stretched string 1 meter in length, fixed at both ends, having a mass of so much, under a tension. It is plucked at a point situated at a point of 25 centimeter front. The stretched string would vibrate with a frequency. Yes. Now here is a logic here. Logic involved. It is plucked, stretched wire of length 1 meter, 100 centimeter, is plucked at 25 centimeter, 50, 25. If it is plucked here, it should vibrate with maximum amplitude here. That means it should vibrate in 2 loops. If it vibrates in 2 loops, 2 times the fundamental. So what is the frequency of vibration? 2 by 2L into square root of T by mu. Everything is given. F is equal to 2 by 2 gets cancelled. 1 by L. What is L? 1 meter square root of T. Tension is 20 by mu, mass per unit length. 5 into 10 to the power mu is m by L. Mass per unit length. Again 1 here. What is this? 4 into 10 to the power 4. 2 into 10 to the power 2. 200 Hertz. Okay. So we have multiplied already by 2. This is not fundamental. Double the fundamental frequency. Double the fundamental frequency means 2 by 2L into square root of T by mu, because it is plucked at 1/4, 25 centimeter. That means here should be maximum amplitude. Antinode, node. So it should be a node once again here. 2 loops. Suppose it was plucked at the center, it would have been only 1 by 2L into. That should have been some 100 Hertz. Now it is 200. Option 3. 52. A tuning fork of frequency 500 Hertz is sounded on a resonance tube. The first and the second and resonance are so you remember that physics experiment, resonance column, velocity of sound. To find out the velocity of sound, you have a formula there. V is equal to 2F into L2 minus L1. L1 and L2 are the 2 resonating lengths. You get the sound for one length, and for the same tuning fork you get the maximum sound for another length. These are the 2 lengths. Simply apply that, that's enough. V is equal to 2F twice the frequency into L2 52 minus 17 into 10 to the power minus 2. 70, and they are in centimeters. If you want meter per second, 1000, 10 to the power minus 2. 10 to the power 3 and 10 to the power minus 2, 10. 17, 3 and 20, 32, 35, 350. Yes, 350 meters per second. 53. The velocity of longitudinal waves in quartz crystal is 5500 meter per second. For a quartz crystal of length 0.05 meter, the frequency of vibration in the first mode. If a quartz crystal is kept between two metal plates applied with an AC, you know it vibrates in the other end, right? And the quartz crystal is free on the, so I will apply the metal plates here, I will apply the potential difference here and make it vibrate here. So it vibrates with maximum amplitude here. So an antinode and a node is formed here, right? So what is the length of this quartz crystal? Length is equal to lambda by 2, because lambda by 4 plus lambda by 4. Antinode, 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 antinode. So lambda by 4 plus lambda by 4. Now their question is, velocity of longitudinal waves in a quartz crystal is so much, and for a quartz crystal of length 0.05. 0.05 should be fundamental mode. In the next mode you can have two more quarter loops. 0.05 is equal to lambda by 2, lambda is equal to 0.1 meters. Then what is frequency? F equal to V by lambda. What are the waves velocity? 5500 divided by 0.1. Oh, frequency is 5500, one more zero, 55,000 hertz. That is 55 kilohertz. Yeah, not 550 kilohertz, 55 kilohertz, 55,000, because for this 100 one more zero will add up. 54. Steel rod 100 centimeter long is clamped at its middle. centimeter long. The fundamental frequency of longitudinal vibrations of the rod is given to be 2.53 kilohertz. Speed, again same problem. So it should be like this. It should vibrate with a node here, antinode here. Lambda by 2 should be 1. Lambda should be 2 meters. Lambda by 2 is 1. Lambda is 2 meters. Frequency nu f v is equal to f lambda. Speed v is equal to. Did I divide in the last problem? What about the last one? Did I do it proper? So we will finish this. V is equal to f lambda. V is equal to f 2.53 kilo lambda. Lambda is 2. Last time we found out frequency, right? V by lambda. Now frequency is given. Yes. 2 into 3, 6, 10, 5. 5.06 into 10 to the power 3. So 5060. Option 1. Direct. 55. Two organ pipes of lengths 50 and 50.5 centimeter long, sounded together, produce 3 beats per second. Their frequencies in hertz are, yes. They have given the difference in frequencies, and you know which one minus which one, higher minus lower. That is also known, because you see 50.5 centimeter is longer, lesser frequency, because these are what pipes, open or closed, whatever it is. Frequency of vibration is inversely proportional to length. For an open pipe, V by 2L. For an closed pipe, V by 4L. You see this one. F is inversely proportional to length. That means, if I want to write beats, I will take the second one 2, first one 1, 50 and 50.5. 3. Or shall I write, length, velocity, nothing is given. So you can't write this formula, V by 4L, because V, L not given. So what we can solve here? By ratios only. How to solve it in ratios? F1 is, I will write F1, inversely proportional to 50. 50 centimeter, shall I write it as 50 centimeter only? Okay, 50 I will write. And because when I take the ratios, centimeter conversion will cancel. F2 is inversely proportional to 50.5. Now F2 by F1 I will make, F2 by F1, because anyway you can do that, because I want F1 minus F2 to be 3. I want to invest it here. I want to substitute that somewhere here, so that solution becomes easier. If I want F1, okay, whatever it is, F2 by F1 is equal to 50.5 and 50 here. F1 50, F2 50.5. Now what I have to do? Minus 1 or 1 minus? This will be lesser than 1, so minus 1 minus 1. Oh, no, 1 minus, correct? 1 minus, 1 minus, 1 minus. Because this answer is less than 1. So 1 minus, 1 minus. 1 minus here, 1 minus here. F1. F1 minus F2, correct? Is equal to 50.5. 50.5 minus 50 implies, this is 3 beats per second. By F1, this is 0.5 by 50.5, correct? 50.5. Multiply it now. You will get one frequency. Another should be 3 times that. 3 hertz more, 3 beats. No, 3 hertz less. F2 should be lesser. 50.5. 3 into 50.5. That implies 15, 1, 15. 151.5. Yes, is equal to 0.5 F1. 0.5 F1 is equal to 151.5. What is that? F1 is equal to by 0.5, 151.5 by 0.5. That means this into 2. 0.5 is half. So into 2 means 0, 3, 10, 3. 303. 1 is 303. That is F1, greater. Lesser denominator, greater. Another one should be 3 beats less. 300. 303. Correct? 303 and 300. This should be lesser by 3 hertz. 3 bits. So option is 2. Okay. 56. 2 parts of a sonometer wire are divided by a movable bridge, differ in length by 0.2 centimeters. Yeah. Two parts of a sonometer wire divided by a movable bridge. Okay. Here one. So this is fixed here and this is passing through a pulley. So they differ by 0.2 centimeter. I'll take this as L plus 0.2 I'll take. Okay. They differ by 0.2 centimeter. Produce 1 beats per second when sounded together. Plug this and this will have a length, accordingly it will vibrate. Plug this and this will produce another frequency. And I will take this as F1 greater, F2 lesser. Sorry, this one F1 greater, F2 lesser. Because this length is less, this length is more, plus 0.2. So this should be lesser one. They produce 1 beat per second. That means F1 by F1 minus F2 is 1 beat per second. When sounded together, if the total length of the wire is 1 meter, frequencies are. Total length of the wire is 1 meter. What are the frequencies? Again, the same procedure. Frequency is inversely proportional to length. Now, total length is 1 meter. L plus 0.2 is equal to 1. 0.2 centimeter or meter? 0.2 centimeter. So this is 100. No problem. Because this is centimeter. So this is 100 centimeter. So you should be very careful. 0.2 centimeter. This is 1 meter. So L plus 0.2 is equal to 100 meter. Then 2L is equal to 99.8. 0.2 minus, if you take it, L is equal to, divide by 2, 4 times, 9 times, 49.1. So one is 49.1, another is 51.1, right? Difference is 0.2, correct now? 49.9, 51.1. So 0.2 difference, that is correct. Length is over. Now they give 3 beats, 1 beat per second when sounded together. Okay. So F1 inversely proportional to 49.9. F2 inversely proportional to 51.5. Divide. Again the same procedure. You have to find out the frequencies. Yes, f1 by f2 is equal to 51.5, 49.9. What you will do? 1 minus or minus 1? Minus 1, minus 1, minus 1. Why? Because this is greater than 1, so minus 1. Minus 1 here, of course, f1 by f2 minus 1 is equal to 51.5 by 49.9 minus 1. So that implies f1 minus f2 by f2 is equal to, what is this one? 49.9 common, 51.5 minus 49.9, that is itself is 0.2. 0.2. Everything in centimeters, so gets divided, no problem. This is 1 beat per second difference. 1 by f2 is equal to 0.2 by 49.9. That implies f2, you bring it here, f2 is equal to 49.9 by 0.2. By 0.2 means into 1. 1 by 5 into 5 into 5. 1 by 5 is 0.2. So multiply this by 5. What is f2? Is equal to 45, 49, 49, 49, 24. 249.5. Now what is that question? Frequencies are, one is 249.5. This is lesser. Another is 250.5. More. Because f1 is more, right? 250.5 and 249.5. That is the answer. Similar to the previous one, but you should carry on with the mathematics also. Steps. 57. Two wires of radii r and 2r respectively are welded together end to end. Okay. Rub this. Two wires of radii r and 2r are respectively welded together end to end. Okay. R. Okay. This combination is used as a sonometer wire. Okay. And is kept under tension T. Tension T, tension T, because they are through a same tension. The welded wire is midway between the two bridges. Okay. That means L, L. The ratio of the number of loops formed in the wire such that the joint is a node, and when the stationary vibrations are set up. This is a node, and how many loops are produced? How many loops are produced here? How many loops are produced here? Because number of loops may be different. So how many? So who is fighting here? Radius, no tension, no length, no, not in the competition. Radius and number of loops. Frequency n by 2l square root of t by rho pi r square. Number of loops and radius. Root of r square comes here. Number of loops is directly proportional to radius. Did you get that? No competition, and because the vibration is together, length no competition, tension same, vibration should be together. This cannot vibrate with different frequency, this one. Only number of loops may be different. Then rho, pi and everything. So bring r here. Number of loops is directly proportional to r. 1:2. Number of loops. Yes. Because radius is 1:2. 58. In a stationary wave, the phase difference between the particles at any two consecutive nodes. Particles at any two consecutive nodes. At consecutive antinodes, yes. Here and here. When this particle is going up, this will be coming down. Particles in the adjacent loop are having a phase difference of 180 degrees. Pi. An empty vessel is partially filled with water. The frequency of vibration of air column in the vessel, as the vessel is filled with the water more and more and more and more, length of air column goes on decreasing, decreasing, decreasing. Frequency of vibration, whether it is open pipe or closed pipe, is inversely proportional to length, and length increases, when length decreases, length of air column decreases, frequency increases. That's why you just take a, in home, however you are in house, take a long mug or a long vessel, keep on pouring water into that, observe the sound. the frequency keeps on increasing because length of air column goes on decreasing. So frequency increases. 60. In a stationary wave, all the particles of the medium, yes, all the particles of the medium cross the mean position with the same speed. Wrong, right? All the particles of the medium do not cross the mean position in the same speed. Different speed but at the same instant. Wrong. Cross the mean position with the same velocity. Wrong. Cross the mean position with different velocity but at the same instant. Yes. At the same instant they cross the mean position with different velocities. Cross the mean position with different velocity at different instant. Where is instant has gone? So no, wrong. Option 3. This is the correct. Sorry. At the same instant, right? That is correct. Cross the mean position with different velocities at the same instant. Okay, that we have given a small idea of waves, but somehow we have tried to cover almost all the portions. So study them. I may not be able to complete all the first year portions, I don't know. I will try with the test paper from tomorrow onwards, right? Because that is very important. And in CET you need not worry. In first PUC portions, the amount of marks allotted are only 25%, right? Some about out of 60 questions, 15 to 18 questions will be from first PU. Sometimes we may not be able to distinguish them because some first PU techniques will be used in solving second PU questions. So we may not be able to distinguish whether it is first PU question or second PUC question. So even if you have left with some first PU portions, don't worry. Thorough with only those portions which you have covered very properly. What you have read, you must be able to remind it in the examination hall. Otherwise it is of no use. So there is no 100% preparation. So you keep on reading yourself. I will try to see the next chapters to be covered. I don't know whether I can cover it or not. But we have covered most of the portions. First PUC portions are less asked. The questions asked from first PUC portions are less in CET. So you need not worry. Okay. So next I will discuss one test paper, and I will give it to you, and you try that question paper. Then we will discuss it. Okay. Thanks for watching my class. Keep on working, and examination is approaching. Don't waste time. And this is the best time to prove yourself because most of the students are not reading. So you can overtake them very easily. So that is the best time to overtake the friends, right? Thanks for watching me. Keep reading. Take care of your health. Let us meet in the next class with the test paper. Thank you.